on that practice and just what do you?
I just got a sandal in my face.
They're already melting.
There's two suns? When did that happen?
This is This is the sun. This is carbon dioxide.
Whoa.
I don't know anything about it.
We want to see if there's a convection current.
That would be the data. Wisconsin has.
Can you open this for me? Or here, wait. Do you want to hold this? Here. Okay. Can you take this? So what I'm going to try to see is if there's a convection current, because the cold water, which is this, is going into the warm water, which was 70 degrees, and it's now dropped to 60. And so what I'm going to do is I'm going to see if there's a convection current, which is where it goes like this. So. Okay, so this may or may not work. Let's see. Okay, so it is lowering, but it might not rise because there's not enough heat going through. No, it's going up. Oh, it is. So it is sort of working. Here, wait, let me get this again. Wait, don't. Don't. It's melting so much that they're dropping out. Look at it.
You do it.
I would like, well, not everybody stands.
From heat. I'm officially done.
Not the big.
Dude, put on your
This is
shoes.
my project.
Is this Dagger? You make our communications like you make fun. I remember the case. I was like, Mr. Dagger is answering
What? So we're measuring the light levels in like the forest, and then we're gonna make a model of like the light. What are you doing?
Measuring how the melting ice caps, which is this, affects the rising sea level. And my first one was the ice was in here, and now this is the second one. And because this one's on land, and I'm going to see which one melts the fastest. The last one melted in 13 minutes. I don't know how fast this one's going to melt.
So you have to stand here for that long? How warm is the water?
So right now it is 62. But if you put your hand right here, it's really warm.
How did it track?
Good, I got second. Or one.
That shows your time.
Under 6 minutes, that's all I know. So it was at 12 and 8/10, and now it's at 13 and I think 3/10. Can you come here and hold this? Just hold it like this. Put your fingers on it. I'm going to show the convection current and see if it's increased at all.
Yeah, just first
It has lowered it. It has, do you see it's staying at the bottom because it's more dense. The colder water is more dense. But then I think it might start to rise. Because it's going over here where the warmer water is, and now look, it's rising. I think. I think it's more that what I think is happening right now is that the cold water is here and the warm water is here. So it's kind of, instead of going vertical, it's going horizontal. The convection current is. Which is sort of weird. Kind of cool.
Your foot on your shoes. It's like super.
What if there's a fire drill?
What if there's a fire
Are you
drill?
taking the sound out of this?
Yeah.
Okay.
Or a bell.
It's dropped 1 more degree. And now it's at 13 4/10. So it's
No, that looks
on
higher.
its way to rising an inch. What? It was at 12 and now it's at 13. So this is kind of weird. I wasn't expecting this to happen at all.
That's so cool.
I'm gonna ask Mr. Stiger what's going on. We were thinking that it might have a natural convection current, but not really. So it's been 7 minutes, and I think so it's been about 10 minutes now. My hypothesis is right so far.
How big of a ruler? Whatever.
Oops. Oops. Uh-oh. Uh-oh.
I love these granola bars. You know, if I had a fish that would eat peanut butter, I would love that kid. Give me like a peanut butter fish.
Don't end it.
Not.
What's going on? Oh, jeez. That's crazy. I was trying to get it up, and it was like, it won't stay. It was like this before. Why is it drifting? Okay. Well, the ice has started to drift now. And I can't do anything about it. It's cool.
Let's see what it's at, Ava. Oh, 13 and a half.
What? It raised that much. Okay.
You touched the can.
So the ice is almost gone. And it's been approximately 11 minutes, 13 minutes. And the convection current doesn't really seem to be occurring. It seems that the dye is stagnant. And the water has now reached.
I know, we have to pick them out. Okay, I grabbed this one. It looks like a tree.
What are you guys working on?
Oh, this is my project. I'm working on how melting ice caps affect the rising sea level and could eventually affect the coastal population.
And what did you have to do today? What was the
So, what I'm measuring how fast and how it is between when the ice caps are in the water and how fast it is compared to on land.
Okay, great. So can you pretend I'm not here and do your experiment that you were doing today?
It's almost finished, so
All right, so
Okay.
just fake it for me, all right?
okay. Right now, I'm just videotaping. So.
Well, that's one of the variables you can change. I think the terminology vocabulary is for that. To me, what I think of as divide, I think of it as right there. That's the divide right there. Watershed.
Wait, can I bring someone else in right now? I kind of need. Okay, Hannah, could you move this?
Is that ink or something?
Yeah, it's food coloring. I'm trying to see. So yesterday, when I had it, I put in the water heater to represent the carbon dioxide and how it was warming the waters in like the Caribbean, and so that created a convection current. I'm seeing if there's a convection current here today, even if there's not a water heater. A convection current is where so. Warmer water is less dense, so that means it would rise. And when there's ice, when the warmer water rises, it cools off by the ice, and then the colder water is less dense, more dense, and so then it would fall. And so it just creates a cycle of like this up and down.
So why don't you look into the camera and tell me what your whole experiment's all about. First of all, introduce yourself, okay? And I'll tell you when to go. And then what you guys are doing next. Go ahead.
Okay, so I'm Ava, and I'm doing a science project on how melting ice caps affect the rising sea levels and the coastal populations, and I'm trying to see if it may or may not affect Wisconsin. So what I've been experimenting today is yesterday I created an experiment to see if the melting ice caps in the water how fast and how much it affected the levels of the water and how fast it did. And now I'm doing it that the ice caps were on land and how fast and how much it rose. And I'm trying to see how that could affect the coastal population.
And what were you just doing before with the...
So then a part of what's happening with the melting ice caps is the convection current, and that is where the carbon dioxide levels are warming the waters in areas, and so partially when the Caribbean waters, I messed up.
That's okay.
Okay, so and so I was trying to see if the water heater that I put in yesterday had was warm, and that created a convection current because the ice was on top of it. And the convection current is when the warmer water is less dense, so it rises, and the colder water is more dense, so it would fall. And so when the warmer water rose, it hit the ice, cooled off, and then went down and created a cycle. And that was with the water heater, but now there's no water heater, and I was trying to see if there could be like a natural convection current. Because
Why were you filming everything?
because I'm going to create a documentary on it and see like my conclusion and if it actually makes me work out.
Great, thanks.
And also have that good video.
Darn, I did terrible.
Dude, you did good, nice job.
So it is now 61 degrees. 13 and 6. 13 and 6 times.
That was model.
For now? No, here, it's fine. Where do I model? I was gonna do
All right, so you do the tornado scale, so you have to identify from weak to strong. So the sticks are gonna represent what? So you use a branch to model a tree and then simulate the breaking.
Oh my gosh, guys, you know what I forgot to do? I forgot to explain why the water heater was in there and what these were. Just
Okay, so you might be instead of modeling, making a simulation. You might just use tools.
can I fill up a beaker with water?
It doesn't have to be an actual.
Hannah, could you hold it one more time? I want to see.
Good solid stabilization. Now, the one end might be need more stabilization than the other place. It'll be all the stuff in between those extremes. You know, how much we change, how much we change. What's your?
Yeah.
Haley, how's it going?
So I'm actually measuring it out.
So, what are we measuring?